This is another example of how to use counting techniques to solve a probability problem when the outcomes in the sample space are equally likely. So this is a problem from the book, and I'm going to just go ahead and read it. So the problem says a company orders supplies from M distributors and wishes to place N orders where N is less than M. Assume that the company places the orders in a manner that allows every distributor an equal chance of obtaining any one order, and there is no restriction on the number of orders that can be placed with any distributor. Find the probability that a particular distributor, say distributor 1, gets exactly K orders. So in this problem, let's first figure out the number of outcomes in the sample space. And the company is going to place these orders, these N orders among these M distributors. So I think it's helpful to actually think about how they would do this. So they would take their first order out of here, and they would go to their pool of M distributors, and they would choose a person to give it to. So for that first order, there's going to be M possible choices of who they could give it to. Then they're going to go back to their orders and pick their second order, take their second order, and pick which distributor that they're going to give it to. And so there are again M choices because a distributor can get more than one order. There's no restriction on the number of orders. So if we want to think about this in terms of kind of slots that we're trying to fill in different ways, we can think of the slots as the orders. So there's order 1, 2, 3, 4, all the way up to N-1 and N. Sorry, there are these N orders. For the first order, there is M possible distributors it could go to. And because distributors can get more than one order, there's still all M of those that are eligible to receive the second order, and so on. So you just go down the line, and for every single order, there are M possibilities. So the total number of outcomes in the sample space is M to the nth power. So this is the number of outcomes in S. So notice this would include things like one distributor gets all N of the orders, or maybe distributor 1 gets 2 of them, and distributor 2 gets all the rest. So this definitely includes repeats. And there could be, since the number of orders is less than the number of distributors, there could be outcomes where there is a different distributor for each order. Okay, that's the number of outcomes in the sample space. And so we need to find the number of outcomes in the event that we're interested in. And we're interested in the probability. So the last part says find the probability that a particular distributor, say distributor 1, gets exactly K of the orders. So we know in our probability the bottom number, the denominator. We need to know the numerator. So the probability that a particular distributor gets exactly K of the orders, we want to figure out all the outcomes in that event. So let's just write out the orders again. 1, 2, 3, 4. These are the orders. ... And then N-1 and N. So the probability that distributor 1 gets exactly K of these, in order to figure out how many ways that can happen, we can first figure out which group of K orders out of this group. We need to pick a group of K orders out of N to give to distributor 1. And so that could happen in lots of different ways. You know, you might say this distributor 1 gets this one, distributor 1 gets this one, distributor 1 gets this one. But the idea is you're going to be picking K of these slots. And notice that the order that you pick them in isn't going to generate a different assignment of K orders to distributor 1. So this is going to be a combinations. So you're going to have the combinations of K things chosen from N, or N choose K is the number of ways to assign K orders to distributor 1. Once we've assigned our K orders to distributor 1, there's going to be N minus K orders left. So N minus K orders are left. Those are the empty slots up here. And those empty slots need to go to a distributor different from distributor 1. So these need to go to a distributor different from distributor 1. So since there are m distributors, there's going to be m minus 1 left that you can assign these n minus k orders to. So there are m minus 1 distributors left. So for each of the empty slots up here, for example, this order number 1 that didn't get assigned to distributor 1, there are m minus 1 choices for who order 1 could get assigned to. Okay, and then same for order number 3. If order number 3 didn't get assigned to distributor 1, there is again going to be m minus 1 choices, because you don't want to assign it to distributor 1. So we're going to have m minus 1 times m minus 1 times m minus 1 n minus k times, because there are going to be n minus k empty slots. So there are going to be m minus 1 times m minus 1 and so on, all the way down to m minus 1 n minus k factors is going to be the number of ways we can assign the n minus k orders to someone other than distributor 1. So that's going to be m minus 1 to the n minus k. And yeah, so these are the ways we can assign the n minus k orders left that go to someone different from distributor 1. So we just need to multiply a few things now. We need to multiply n choose k, which is how we assign the k orders to distributor 1, with m minus 1 to the n minus k, and that's going to be our numerator. So finishing up, the probability that k orders go to one distributor, and it doesn't matter if it's distributor 1, so we can say distributor 1, but it'd be the same thinking for any other single distributor, is going to be on the bottom m to the n, on the top n choose k times m minus 1 to the n minus k.